Hello, everyone. Thank you all for coming. Today we're going to talk about a field research project and the carbon cycle and some real-time measurements of what's going on in rangelands with carbon. This is new stuff. As far as we know, hasn't been published before, so we're really excited to share some preliminary results with you. Our two basic questions are, well, how much more or less production will we find under managed grazing? And how much more or less carbon is sequestered under managed grazing? Heaton is the rancher that is running this project. We're using his pasture, and he's the one that basically set the agenda when it comes to the practices. But one of the things that a lot of ranchers have been asking, including Lewis, is, well, are we getting any carbon benefit with our management systems? So I'll briefly talk a little bit about carbon as a carbon cycle scientist. Lewis will talk about the experiment and what we're doing out there. We'll give you an overview of some findings from this last summer. We just started this last May. And then we want to just talk about the potential opportunities in rangelands. First of all, maybe all of you know, but carbon dioxide comes out of the air and goes into plants, and some of that carbon that's fixed by plants, carbon dioxide becomes, organic carbon, and then that's transferred below ground. And one of the things Lewis asked me when I first met him in 2019 was, how do we really know what our carbon numbers are? How do we really know in our rangelands how much carbon we're sequestering per year, especially in a managed grazing system? And he was interested because he realized that customers or consumers are willing to pay for carbon credits. And that seems to have gained a lot of traction in recent years. More and more people are more open to the idea of buying what they call a carbon credit, or paying agriculture to store that carbon below ground that they might emit in something like an airplane ride. Like when I bought an airplane ticket, they said, do you want to buy some carbon credits for the amount of carbon dioxide you're emitting when you take this, right? So apparently there are some people that are willing to pay, but in order for that carbon dioxide to be removed from the atmosphere, it has to be buried below ground. And this happens naturally in grasslands. And I wanted to be sure and say also that feel free to interrupt with any questions you might have as we go along. You don't need to save them for the end. So where you don't mind an interactive kind of session. So if people are willing to buy these carbon credits, Lewis was interested in the financial benefits possibly to range managers. And because in his mind, he said, I really think that we're sequestering more carbon in these grazing systems. So basically, there's a lot of uncertainties around the carbon cycle specifically, but perennials store more carbon than annuals, and that in grasslands, a great fraction of their carbon that they fix from the atmosphere is sequestered below ground. And that could be in roots, it could be in the fungal associations, there's carbon in microbes, there's lots of different places where there's carbon. And carbon is basically a proxy for soil health. So a lot of people talk about soil health and the importance of it. What a measurement that they commonly use to give them an indication of how healthy their soil is carbon in the soil, as well as, or you might also have heard the term organic matter. But with more organic matter, more carbon, you have better water retention, better nutrient retention, erosion protection, and like Gene Govan has talked about, a lot of better water infiltration. So we've known for a while now, based on sophisticated measurements all over the world, that grasslands are carbon sinks. So a colleague has published this paper saying we've looked at flux tower systems, these systems that measure carbon dioxide in the atmosphere and how they move into grasslands, and it makes sense because the grassland allocates so much of their carbon under the ground. So we know that they're carbon sinks, but this whole issue of how does management affect the carbon sink is not something that has been well researched, because it's difficult to do. Particularly on working lands like Lewis Heaton's here. So we wanted to know, can we enhance that carbon sink? Is there a carbon benefit, not only just a soil health benefit, but also a carbon benefit? And as many of you probably know, with the grazing management systems, you've seen a lot of positive outcomes. As Gene Govan in the last talk synthesized, but again, we're still not sure. We would assume if we're getting more production that we're getting more carbon, a greater carbon sink, but we weren't for sure about it enough to be able to say, here are the numbers. When we graze, these are the numbers. And when I look at the literature, I see different people saying, oh, well, well-managed cattle will sequester carbon. But then you look at the citations and you don't see data behind these assertions. Again, there's a strong reasoning to think that, rationally that, well, we should be sequestering more, but it's very rare to find the actual data. And that's what Lewis came to me asking about, how much carbon is really sequestered. And through partnership with the North Dakota Natural Resources Trust and our other funding agencies, we were able to get this project started last year. I operate a nonprofit, a small nonprofit. I used to work for universities and Agricultural Research Service, but these kinds of projects are sometimes better suited for those that are very nimble, that are able for smaller organizations that can do these types of projects on private lands. At least that's the basic idea of small projects, maybe short-term versus these longer-term research station and university projects. So that's what makes this a little unique, is we needed to get this project. We were told that we had the award last December. We had to get this project up and going and in the field by May, and which we did. And Lewis will go through all that. And the way that we're doing this is with year-round ecosystem scale measurements. We will not have the whole data picture for you at this stage of the game, but we are able to show you some preliminary data which looks promising. Briefly, how carbon is commonly measured is, as you likely know, with soil sampling, and in that case, we're basically burning soil samples, so to speak, to determine how much of what's burned is carbon. And that's very good point data. You can actually go around and take a bunch of cores. But that has its limitations because you're looking at parts per 100 measurement. You're looking at percentages. With the fluxes that we're measuring now in projects like this one, we're actually measuring the molecules of carbon dioxide that are moving in and out of that ecosystem over around 50 acres. So it's what you call an ecosystem scale, and we're measuring in parts per thousand or parts per million, and so it gives us the ability to look at what's going on not only in the soil but all the other places that carbon is residing, like roots and microbes and things. This is a picture of that unit. And it's what you call the gold standard for carbon dioxide fluxes. We were fortunate enough to have support for this through the Industrial Commission, as well as our other conservation partners. What we're doing is we're going to be providing annual carbon dioxide sequestration or annual carbon dioxide uptake in that ecosystem over the course of an entire year, with these measuring winter, summer, day, night. So that's, if you can kind of imagine what we're doing, and the budget to know how much carbon is in there that you actually sequestered has to take into account not only all the carbon dioxide that moved into that ecosystem, but also what was harvested. So that's why we need to know what the cows are taking off in these grazing systems. So there's a lot of field measurements as well as these sophisticated systems that not only measure carbon dioxide, but also all kinds of other weather-oriented variables and, in 30-minute increments. So it's a lot of data point. So I'll turn it over now to Lewis.
Thank you, Dr. Phillips. I'm Lewis Heaton, and I ranch in south central and southwestern North Dakota, and I have a lot of interest in this project. You know, I've followed the carbon market for a while, and while I have an interest in the actual carbon cycle and I've tried to kind of determine what its value might be for my ranching enterprise, in addition to all the other benefits we get from it. It's a working lands program. This particular on that particular ranch, we have 150 cow pairs that we run through it, and you gotta show me. Is this the one we hit? Okay.
Yeah, that one when you're ready.
And this is on native rangeland where we set this up, and we set it up in paddocks. Let's see, I gotta move.
Here, I can do it for you.
Thanks. Yeah, this is the outline of the pasture here. This is north of McKinsey. Where we got it set? It's like I said, it's native rangeland, and we set it up with these 4 paddocks here, and you can see the shapes are kind of odd looking, but that's kind of the configuration you have to have, that those instruments can sense about the distance away from the center where they're set up here. And we actually have 2 of those. There's a control unit in a pasture here that's not grazed, and then we have up here we have the 4 pastures that are in our system. And you can see this is how we graze it in 2023. We went mostly one to 2 days in each paddock, depending on what kind of removal we could get. We tried to get about 50% of the forage removal before we moved them, and depending on the weather, we kind of have to determine that when you get started on it. But we did 1 graze a month. We did 1 in the spring, 1 in the early summer, late summer, and autumn, which kind of came out to like June 1st and July 1st and August 1st and September 1st. And then and on this 2-year project, of course, next year we will do we'll change the season of use on these pastures here. And of course, we alter the season of use, and we do monitor the species cover, the 50% of the targeted leaf area removal. It's pretty much a high intensity, short duration grazing, and we track the forage recovery with CO2 and biomass data. They take grass clippings before and after each grazing event, so we will know. We did come pretty close on the 50% removal. Some was in the mid to upper 40s, so we came out pretty close on that part. And that's what the system looks like. It's getting, the light isn't too good here, but that's the system that can measure the actual CO2 that comes into the soil and goes out of the soil. And we did graze 50% each leaf area. And yeah, it was really interesting. And then we'll also know a lot about there was a botanist there that did a percentage of the species that are on each of the paddocks. So we have a lot of, we've gathered a lot of information, and now we'll figure out what we're going to do with it, I guess. We have the forage data that we collected before and after each grazing event, and it's a lot of work, actually. They have to take the grass clippings and dry them and weigh them and then separate, what you have of each one.
Can I interrupt now?
Yeah, go ahead.
And this is where I have to give credit to Abrielle Tembrell. She just joined our team last summer, and she was the one that was in charge of the forage data, where all these frames were set out there and clipped. All the biomass was separated into green and brown vegetation. The green vegetation went through a leaf area meter, a scanner, to find out exactly how much leaf area there was before and after the cows grazed, and as well as drawing it and weighing it and making sure we knew exactly how much biomass, dry matter, there was. Again, because we need to know how much they took off in order to construct the budget. And here's the data where you can see in May 1st, there was basically no green leaf area last spring because we had such a late spring. But by June 1st, both the control and the grazed area were similar. And then by July 1st, again, they were pretty similar. These are all pre-grazing data. But by the 1st of August, now we're starting to see some differences between the two. In the grazed paddock was slightly higher. That difference persisted into September and even into October, this last October. But by November, Abrielle went out again and found that they all had similar amount of green material. So this is only the green veg, sort of this season's growth that you're seeing in this graph. We also have leaf area data that tracks this as well. But this gives you and when I showed this to Lewis, his first thought was, well, we're just extending the growing season. So by having more green leaf area later in the year as compared to the one that wasn't grazed. Now, of course, when you're doing these kinds of grazing experiments, there's 100 different ways to do it. And some people say, well, we shouldn't have used an idle pasture control. But this is our first cut at something like this, so we wanted to use as close to a true control as we could. A lot of people like the idea of comparing it with season-long grazing or something, and maybe those kinds of things will be feasible in the future. This is our first year. And this is the one entire array of the instruments here. You've got the flux measurement, you've got a solar panel with a battery, you've got the computer, if you will, the logger that logs all this information, rainfall data, you're getting soil temperature, soil moisture, radiation information, so that we are actually tracking not only the carbon dioxide that moves in and out of that system, but we're also tracking water vapor too, and energy as it moves in and out of that system. And so we have a camera out there full time. So keeping track, so any movement in any of these are very expensive instruments, is being logged with the camera, and again that's a close-up look of basically the main brains of the most sophisticated part of this unit, where this is high frequency wind speed and direction information. The way this works is you're getting vertical fluxes of air. Right, so you've got eddies of air, and not only usually when you think of wind speed or wind direction, you're thinking of this just horizontal, but this we're actually capturing vertical. So eddies of air move in and out of this ecosystem, and this is collecting data now at 20 times a second. So this and in those eddies of air is material. There's carbon dioxide as a gas inside that eddy, as well as water vapor. So this net flux, what it does is it tells you that net amount over a half-hour period of time that's coming into your system. So if at nighttime, for example, you're going to see more carbon moving out of the system than coming in. So that net would be more of a moving out net. But in the daytime, when plants are photosynthesizing, you're seeing more carbon dioxide moving in because the plants are using that carbon dioxide. So that's moving into the system, and that would be carbon uptake, and when it moves out of the system, you might call that carbon release. And so this is being tracked continuously over time, so that we'll be able to understand what's the total amount of carbon overall, the net the number that you'd have, that we have. And this net number includes not only the grass you're seeing that we clip above the ground, but it also includes the carbon that's going into roots, the carbon that's going into mycorrhizae, the root exudates, the microbes, all of those things is all included in that net flux, which makes this different than soil sampling. I also spent a lot of time doing soil sampling, which is also very good, but it does measure something different than what these guys are measuring. And like I say, you're getting parts per million type precision. So so I want to spend just a little time talking about this because this is pretty new stuff, and this is a cumulative carbon dioxide uptake. So what you see here on May 1st is at the first couple weeks of May, it's pretty flat because it was very cold. We didn't have any green material till mid-May, or a substantive amount of green material. So what's happening is these two lines, you're seeing little squiggles in them. That's telling you that there are, that's day and night. When you see a squiggle, that's, well, daytime is slightly different than nighttime. You get a little bit more loss of carbon at night, more gain of carbon during the day. So you keep adding up day by day of every half-hour increment, all these carbon fluxes over time. So then you come up here, and now we're into June. And this is the blue one is the control, and the orange is the managed grazing. Now you're looking at areas of 50 acres in size that we're capturing this information from. And now this, by June, or July, we've probably had 2 grazing events. So there's been some leaf area removal. So you're seeing over here, the grazed plot is not quite as high in the cumulative carbon as the control. This control is reaching its absolute peak season right here. So the blue line, it peaks out here in July, and then it slowly starts to decline until the 1st of October. As you would expect, plants green up, and then you'll see them senesce every year, especially if they're not grazed. The one that was grazed here is you see it. What you're seeing is, okay, it's impacted by the leaf area removal, but then it recovers, it comes back. And now that carbon is moving, and it is just like you saw in that biomass graph, you're seeing in these later months, August, September, you're seeing this one outpacing the blue line. So when you look at this number here, this is where it ended as of October 1st, and this number is higher than this number here, which says that over this period of time, 5-month period of time, you've got more carbon that has been sequestered or uptake into this ecosystem that was grazed than the one that was not. And again, we won't know the whole story till we get 12 months of data, but we're just showing you right now what we're observing in these first 5 months. When I had asked Lewis before I compiled all the data, I said, well, what do you think the difference is going to be between the grazed and the control paddocks and pastures? And he said, well, I'd say anywhere between 20-30%. I'll be darned. That's where we're at, right around 25%. Now, I approach this with caution because these data are just hot off the press, so to speak, and we need a full year to know what the whole year, if for all of a sudden wintertime comes and there's a whole lot more losses of carbon in the grazed, then this would change this. So you got to realize this is just preliminary look at what we've observed that follows and is in accordance with what we saw in the biomass data as well. So I wanted to make sure that you all got a good look at that, and if anybody has any questions, if I wasn't clear, please let me know. Yes?
How is that measured? Tons per acre? Or?
This is in, yes, metric tons per hectare or metric tons per acre, but yes, in tons per acre or tons per hectare.
Do you have a number of what that was at the beginning?
And at the beginning, we were at May 1st. There was that was our start date. So that was ground zero, there's no green vegetation yet. And then over here, we're seeing, you know, in this one, we're getting over 1,000, you know, we're getting at least 25% more in the grazed one, but I'm not yet comfortable in saying exactly, you know, how many metric tons yet at this point. Okay. Oops, okay. And again, I just wanted to reiterate this concept now of the difference between the clipping studies and this kind of work is that we're talking above and below ground. And what you see over here, and this is in pounds per acre, what we're seeing above here is the above ground vegetation in pounds per acre. And what we will show at the end of this first year will be in units of carbon, tons per acre, and it will include the carbon that went above and below the ground. And so I just wanted to make that clear. And then I'd leave it to Lewis to talk about more about why we would care about carbon here in rangelands.
Get in the way. And some of my interest has been on with this project is the actual business side of it. You know, is it as we move forward, carbon is starting to be considered actually a commodity. It's something that's going to be bought and sold. And since we think we can capture it, you know, there's probably going to be a market for it. Well, there already is a market for it that's kind of in its infancy, but there are companies that will make you an offer. I personally have had one and looked at it already, but we can go through that a little bit. Anyway, nature-based, you know, which is what we're doing is you know, we're taking something that scientists in the CO2, scientists believe we need to take it out of the air and try to lower the CO2 and the actual number. And with nature, we can do certain things with our soil in having a improved grazing system where we rotate. We know we can do certain things. We can get more production, and that would lead us to the assumption and the actuality that we can also sequester more carbon with that. And there is it's kind of a complicated system when you look at an offer. There's different pricing for different types of quality carbon credits that we can do on rangeland. If you have a really, really intensive improved grazing system, you will get a higher score, and you'll get a higher payment level. Some of the funders will pay more for a high quality carbon credit. And one of the things, I don't know how many of you have seen it, but just here in the last couple of weeks, Microsoft signed a really large contract with Grassroots Carbon. And that's a company that I have had a offer from, and it's like I said, it's kind of complicated. You know, they'll have a graph on there that'll show you what kind of payment you would get for a certain quality of a carbon credit. And if anybody wants to ask me more questions about it later, I can answer them. It's if you haven't seen one before, it's several pages long. It's got a lot of information on it. But the volunteering market is still probably somewhere between $15 and $25 a metric ton. But my thinking is we need to get that price closer to what some of the subsidies are for what the government is offering to for certain types of other carbon capture, like if they're using it for enhanced oil recovery, that's a $60 metric ton payment, and if you use it for the deep storage injection, there's an $85 a ton subsidy for that. So as we go forward, I think we're probably going to close them together, the difference. And I haven't signed a contract, and I haven't done yet. I would like to see the voluntary market get closer to that $50 a metric ton. And most of these companies are like this Grassroots Carbon has probably got, they really only started with their actual contracts probably a little over a year ago, and I think they actually have signed like only 200,000 acres at that point, but they have another 300,000 acres that are going to come under contract quick. So, and you can kind of compare that with Indigo is one of the bigger companies that buys carbon credits for off of cropland, and they are probably somewhere over 10 million acres that they have under their contracts. So you can see both of them have increased the amount of acres and dollars that went out from them. So it is moving forward on that part.
This is just that.
Okay. Is that the end of that?
Almost.
Okay. Oh, one of the other things I got to mention, that this is Will. He's the herdsman there. And when we graze that, just to ensure that we got, my cows are used to being around a four-wheeler, so we actually kind of hazed them around those small paddocks, so we got really good overall grazing. When it's hot, you know, they'll line up in a corner or something. So we think we did a pretty good job on that. And then we have, that's Jesse Becker from the North Dakota Natural Resource Trust, and he's the actual person that's in charge of the funding and running the project.
And then Jed Ryder.
Yeah, and then there's also another station that does things up in Williston, and it's while they don't have the sensors there, you know, there's we keep the weather data and things, and that you can actually, Dr. Phillips, I probably should let you talk to that, because how that can be modeled with what we're doing at McKinsey.
Yeah, our goal is to take this core site data that with all these expensive instruments that is very intensive work, and be able to model it across other grasslands in the state of North Dakota. So we're taking weather stations like this at Jed Ryder's, where we're capturing a lot of those environmental covariates, those variables that also change. When we lose sunlight hours, for example, we're going to change the carbon flux. And so we'll be able to take what we hope will be the imagery that we get from satellites and weather data, and with the model we develop out at McKinsey, we'll be able to apply that model to other sites like Jed Ryder's and other grasslands. So this Jed's is our first satellite site, so to speak, and then we'll keep improving the models so that we'll eventually be able to get a good part of western North Dakota. That's the overall goal, and but we need to have this intensive data set to help us to really tease out what is it exactly that's in the environment and the weather that's controlling those carbon fluxes. So we can get, if we know our soil temperature, our soil moisture, our humidity, all these things. And then we also know leaf area is important too, so the greenness, and we can get greenness information from sensors in the sky. Then we're going to merge all those together in order to estimate, because this is a different area in Williston, to estimate what kind of annual carbon sequestration might we find in these other areas, and so that we can so that tool hopefully would be available to ranchers, so that they don't necessarily have to have something like what Lewis has on their site, but they can have the information they need, so that if they're talking to carbon buyers, then they will be able to say, okay, they'll be able to talk with have some information in those negotiations or discussions. If they wanted to ever sell their carbon, they would have an indication of what their sequestration might be. And we're just incredibly grateful to all of the partners that have made this possible. The oil energy industry is interested in this because they are restoring a lot of grasslands in western North Dakota, and they would like to know how about the carbon that's being sequestered in grasslands and as part of their portfolio in their restoration work. In addition to the conservation partners here, like the Trust and Ducks Unlimited, Game and Fish, and Pheasants Forever, and a number of organizations that have helped to make this possible. This is an amazing project. It got off the ground really quickly. I've been doing this kind of work for over 20 years, so it just happened to be one of those situations where we got all the right partners together, including Lewis Heaton, who is interested in enough in this kind of thing to put up with me, and and my little mistakes along the way, like not knowing how to roll up fence. So, but we're really happy to welcome any questions.
Just a comment, you had said before that somebody said you should be comparing it to season long. I think it'd be interesting to do all three, but I think the control on ungrazed land is equally as important because there's so many people out there that want cattle off the range. But I think the big comparison there is that.
Good point. Good point. Appreciate that. Well, we'd like to be able to, for the model to be able to help us with the season-long pasture of Lewis's neighbor, right? If there's an area not far from this experimental pasture that's season-long grazed, if we can appropriately model those things, we can get a pretty good idea, we hope, of the season-long. Most research institutions would have 4 people working on something like this, and we've got about 2 to 3, and the grazing intensity of it adds a level of complication that's very unique, because we need to be out there at a certain time. Lewis has to be out there. We got to be moving these cows. We got to make sure that they're on and off at the right time, and then we got boom, in another month we got to be ready for another grazing event. And the reason that we are doing these grazing events this way is because Lewis says he likes the biodiversity that he can encourage by not grazing the same season every year. And he wants to see how that biodiversity might shift, which might also help the other elements of the carbon cycle too, with greater biodiversity. Yes?
I'm just curious, so are these month-long, as I'm going to call them, paddocks, are they separated smaller, or are they just in?
So this is not in any way a paddock design we would recommend for anybody. It's that this instrument in this kind of a ecosystem will cover about 50 acres. Okay, and the paddocks that we graze are only 11 acres, and that's why they're only grazed a day or two. And in order to get those 4 different seasons.
So there's multiple small pastures inside these 4?
No, just the one. Each one of them is 11 acres.
Okay.
And the cows go in, and then we have to move them, keep them moving with the ATV, and make sure that they graze as clean, as similarly as we can, not just clump up in one area like Lewis was saying. But it's 11 acres for 150 cow-calf pairs doesn't last too long, depending on the year. But Lewis has a pretty good feel for what 50% leaf area looks like. So we go out there, maybe they're out there for a day and a half, and then it's like, okay, 50% leaf area has been removed. Let's go ahead and take them off now. And
what was the total amount of acres that you're grazing in these 4 seasons?
so it's a 50-acre paddock roughly, and there's about 11 acres in each one. And then the area right behind the instrument is a blind spot that we don't do. So it's not it confuses people sometimes because they think, are you telling us to graze this way? No, it's just that it's the instrument constraints, if you will. Because if I tried to graze that whole, let's say a half section, the instrument wouldn't be able to pick up a half section
So what you guys were doing is you had 4 11-acre parcels. You'd move them in there for a day or two and move them out to a different.
Right.
Right, yeah. Well, we tried to make it as, as a working ranch could possibly be, with like 150 cows instead of like 5 or something. So it is the numbers are something that you would see in a ranch, 150 pairs. And the movement and the things we tried to, do what we would do with an ordinary rotation, something like that. So the other thing I was going to mention, the technology is moving so fast in the kind of the spatial look and with satellite imagery and different types of information that as we go forward, it'll get easier and easier to know what we're doing and the results that you can get from it. But this project gives us a start, so.
And yes?
I just want to make sure I know what it's being said. So as you're taking the measurements from just the paddock that you're doing prior and then post grazing, correct?
For the clipping data, the forage data, we collect from all, we have points along transects for all, for both of them. So for example,
Yeah, but just for,
but the before and afters, the before and after clipping is in the area that was grazed, but the measurements are being continuously for everywhere. So we're getting that whole 50 acres, and I had to take into account that when the wind direction comes from the southeast, and I just grazed that one, that surface roughness, the aerodynamics is different than the one that hasn't been grazed. And all that is in the program so that we can get proper estimates. Because these systems are usually set around systems that are homogeneous canopies, where everything is more or less the same. But we had to adjust this one considerably because they're not all the same at different times of the year. So we have to measure those heights and those vegetation canopies along every week throughout the season to make sure we're properly accounting for those differences in the vegetation. But yeah.
Did you guys core sample it all to measure that against with this machine?
Yeah, we collected the core samples and we separated them into horizons. Went down to about 3 feet. We've archived those, and we'll plan on, if this goes for 5 years, we'll plan on going back and coring and having that information available as well. And we're always welcome university partners or any students that want to work on the site as well when it comes to wildlife or soil or plants or particularly roots would be lovely too. So, but yeah, we're trying to cover as many of the bases as we can. Yes.
When you have the cattle not on the project, are they someplace near that where they can graze?
They're within a mile or two. I have other pastures that join this, so we just run them back out there into another pasture. Yeah.
Are they then brought in about the same time of the day? You said some of it was a day and a half.
Well, one thing I learned about this project when every day grazing is not the same. The weather, when it's really hot, they don't graze a lot. And then some days when the weather is really favorable after you've come off a really warm week or something, they will graze twice as much, really, really fast. So we just keep them in there until we think we've reached that about 50% of the forage removal. That's what our goal is. But that's a visual thing that we have to use at first to move them out, and then later after they've done the grass clippings, then we can see how close we came. And most of them were really close.
Yeah, they were roughly, I think the average was 0.48 or 0.46 leaf area removal. So that's where the actual scanning of all of the leaves before and all of the leaves clipped afterwards told us what we were removing, because that also affects, that's part of the model of affecting the carbon uptake. But we would tend to get them out first thing in the morning, like at 7 in the morning as a general rule. But that timing, we'd keep track of the timing, but it wasn't exactly the same every time depending on, and one time a terrible storm was ready to come through, and we would have liked to have kept them out there a couple hours longer, but it was like almost tornado level warnings, and so we just had to move them, you know.